Th- This lesson is on quadratic functions and application. Quadratic functions are of the form ax squared plus bx plus c, and they're also known as parabolas. So beginning with number 1, if you notice that f of x equals parentheses x minus 3 squared minus 9, notice that there is no reflection, so therefore the parabola opens up. To identify the vertex, if you take x minus 3 and set it equal to 0, you get x equal 3, so it's 3, negative 9. To determine the x-intercept, you set y equals 0. So you're going to add 9 to both sides. Take a square root and put plus or minus the square root of 9 equals square root of x minus 3 squared. Plus or minus 3 is equal to x minus 3. 3 plus or minus 3 is equal to x. And you get 6 equals x or 0 equals x. And remember, the x-intercept is an ordered pair, 6, 0, 0, 0. Okay. To determine the y-intercept, you let x equal 0 and plug it in. So 0 minus 3 quantity squared is 9, minus 9 is 0. So the y-intercept is the point 0, 0. And then to sketch the function, I plotted the point 0, 0, 6, 0, and the vertex, which was 3, negative 9. The axis of symmetry is the x value of the vertex, x equal 3. To determine a minimum or maximum value, that depends if it opens up or down. So because it opens up, we have a minimum value of negative 9. Your domain is negative infinity to positive infinity. Your range is negative 9 to infinity. Make sure you have the brackets because it's included. Okay, number 2 is a parabola. Notice that there's a negative sign in front, so it flips or reflects over the x-axis. So therefore, the parabola has to open downward. The vertex is 2, negative 1. And if we look back at our shifts, it shifts right 2, so that's why it's positive 2, and down 1, which is negative 1. To find your x-intercepts, you let y equal 0, add 1 to both sides, divide by negative 1, and if you remember, the square root of negative 1 is I, which is imaginary, so there's no x-intercepts. To determine the y-intercept, you let x equal 0 and plug it in, and you get negative 5. So to sketch the parabola, I sketched the vertex, which is at 2, negative 1, and the y-intercept 0, negative 5. And then I can either use the fact that we have a line of symmetry, which is x equals 2, or we can use a graphing calculator to help us. Okay, so the axis of symmetry is at x equal 2. Because it opens down, we have a maximum value, which is negative 1. Remember, your domain is negative infinity to positive infinity, and your range is negative infinity to negative 1. Again, brackets to include the negative 1. Now, notice the next form we have is ax squared plus bx plus c, which is a trinomial. So with a trinomial, to find the vertex, we're going to use the formula x equal negative b over 2a. So everyone needs to memorize that for me. Number 3, a is negative 3, b is 48. If you plug it in the formula, you get x equals 8. To find the y value, you go back and plug it into f of x, and you get 27. So your vertex is 8, 27. Number 4 asks us to find the vertex. Notice it's a little bit more difficult because it's only a binomial term. A is 4 and b is 0. So again, if you plug it in, you get x equals 0, and then you have 0, negative 7. On number 5, we have a trinomial, negative x squared minus 2x plus 3. Again, because it's negative in front of the x squared, it opens down. Your vertex is using the formula x equal negative b over 2a. So we plug our numbers in, and we get negative 1, 4. To get the x-intercepts, we're going to set y equal to 0 and factor. Now, when we do this, we have a choice. I went ahead and factored because it's an x squared term. And notice I divided by -1 first. So when you factor it, you get x equal -3 or x equals 1. So again, look to the left. The vertex is -3, 0, 1, 0. To determine the y-intercept, you have x equals 0, so we plug it in. We get 0 minus 0 plus 3, giving us 3, so y equals 3. So our y-intercept should be 0, 3. Okay, next we want to sketch the function. So again, I plotted the vertex, our y-intercept, which was 0, 3, our x-intercept, which was -3, 0, 1, 0, and our vertex, which was -1, 4. Your axis of symmetry is the x value of the vertex, x equal -1. The minimum or maximum value, because it opens down, we have a maximum value equal to 4. Your domain is -infinity to +infinity, and your range is -infinity to 4. With the applications, the main takeaway here is for you to know when you see the word minimum or maximum, we want to use the formula x equal -b over 2a, and we'll find our x value. We usually have to plug it in to find the y value. So the minimum or the maximum refers to the vertex. So if you read the word problem, we have an equation. Okay, so this is supposed to be the equation of the path that a bee follows. So the question is, what is the maximum height? If you notice, I underlined the word maximum. So as soon as you see that, you know we want to use x equal -b over 2a. So you can see the word. A is -0.03, b is 1.8, and make sure you have -b over 2a, or the opposite b over 2a, and you get x equal 30. If we're talking about time or distance, the value has to be a positive number, so I can check myself there. Take 30 and plug it in, you get 3. Then it says, how far away from Sherlock are the flowers? A and B. Anytime you want to find how far or when something hits the ground, that means y equals 0. And in this case, I have to use the quadratic formula. So if you recall, the quadratic formula is x equal -b plus or minus square root b squared minus 4ac all over 2a. Notice we get two positive values of 20 and 40. Looking at the picture, because flower A is closer to Sherlock, flower A would be 20 inches. And since flower B is further away, that would be 40 inches. Okay, so now that you have this, if you need to work back through the notes again, listen to this again. And I would like you to go and try online and Connect Math the homework for 3.1.